Hi everyone, so we're going to go through the covalent bonding revision mat today. The specification points are just shown here on the left hand side, so you can see the pieces of information that you need to know. Let's start on the top left hand side. What is covalent bonding? So I'm just going to start with that question first. Covalent bonding is where atoms of elements share electrons. So share electrons. What type of elements does it occur between? Well, it occurs between non-metals. So it occurs between non-metals. Okay, let's do the one below. Complete the diagram below to show the formation of a covalent bond in a hydrogen H2 molecule. So these are already drawn out for us. Hydrogen has one electron in the outer shell. So if we remember our formation, we like to have 2 electrons in the first shell, 8 in the second, 8 in the third, and 2 in the fourth. That's just our remembering from previous revision that we have done. Okay, so there's 1 electron in the outer shell here for each of them, and they want to have 2. So the way they get around that is by sharing their electrons. So I'm going to draw a cross which represents the electron for this hydrogen atom on the left, and I'm going to draw the other one as a dot. So they're both electrons, they're both the same, but the cross indicates the electrons come from one atom, and the dot indicates it comes, the electron comes from a different atom. So it just shows that I'm aware that those 2 electrons, one has come from the left and one come from the right. Let's go to the next one. Draw a dot and cross diagram showing the covalent bonding in water H2O. Also show the structural formula. So I'm going to bring along my handy periodic table to help me with this, because I've got hydrogen here, so that's already drawn out. So then let's find oxygen. So oxygen is here, it's in group 6, which I will recall means that it has 6 electrons in the outer shell. Okay, so if I put oxygen, so 6 electrons in outer shell. Hydrogen has 1 electron in outer shell. That's just from before. And we've got 2 hydrogens because it's H2O. So I'm going to draw the oxygen first in a circle like this. So it has 6 electrons. It wants to have 8. So if you remember here, 2, 8, 8, 2. So it's got its 2 second shell. It's got 6 electrons. It needs to have 8. So it wants to share 2. So it makes sense that it shares 1 with each of the hydrogens. So I'm going to draw the hydrogen down here with my circle. Oh, it's not very big, is it? Not going to leave me a lot of space so it can share it. So I'm going to put a dot and a cross in each of those. It's going to be quite difficult in this one. I've made it a bit small. I do apologise. Okay, so if the crosses are for oxygen, I've got 2 there. I need to have 6, so I need 4 more. So 1, 2, 3, 4. And then my hydrogens are shown there. I might just make this a little bit bigger around here to show it. Okay, so it says also show the structural formula. So structural formula is the same as this. I'm going to write it out next to it. But instead of drawing the dots and crosses, I literally just represent each covalent bond by a line. So it looks like that. Let's have a look at the one on the right hand side. Complete the diagram showing the formation of a covalent bond in hydrogen chloride, HCl. So it's already drawn out for us. Got 1 electron there. Got 1, 2, 3, 4, 5, 6, 7 there. So you want to have an extra one. So it makes sense that they share it. So I'm going to draw these out exactly as that is drawn there on here. 1, 2, 3, 4, 5, 6, 7. And then this one here from hydrogen, I'm going to change to a dot to signify that electron has come from hydrogen. It's come from a different atom. Okay. Next one, let's go to the one below. Complete the diagram below to show the formation of a covalent bond in oxygen O2. There's no crosses around here at all, so I need to fill that in. So if I go back up to here, I said oxygen has 6 electrons in the outer shell. So I'm going to draw these each with 6. 1, 2, 3, 4, 5, 6. And I might just start this one. If I'm going to draw dots already, 3, 4, 5, 6. That might just make it easier on the next step. So oxygen, that one has 6, that one has 6, and they both want to have 8. So that means they need to share 2 electrons. So I'm going to put 2 crosses and 2 dots in each. Because then if I take those 2 out, there I've got 1, 2, 3, 4 left. So I need to do another 4. 1, 2, 3, 4. And the same on this side. I'm taking 2 out. So I've got 1, 2, 3, 4 left to draw. So 1, 2, 3, 4. So then if I add up each circle, I should have to add up to 8. 1, 2, 3, 4, 5, 6, 7, 8. 1, 2, 3, 4, 5, 6, 7, 8. Brilliant. Show this as a structural formula. So I remember my structural formula. I just have the letters and then draw a line for each covalent bond. The covalent bond consists of a cross and a dot. So here we've got 2 covalent bonds. So I need 2 lines. Okay, last one. Complete the dot and cross diagram showing covalent bonding in carbon dioxide, CO2. Also show the structural formula. Okay, so oxygen has 6 electrons, so O equals 6 electrons in outer shell. And then I need to look at my carbon, so let's bring back my periodic table. So carbon here, it's found in group 4, so it has 4 electrons in the outer shell. So C has 4 electrons in outer shell. Okay, so the carbon will be sharing the electrons in there. So let's have a look. It will be sharing. Well, carbon wants to make 8, doesn't it? So we need to share all of those 4 to make 8. And oxygen wants to make 8 as well, but it just needs to share 2, like we've done here on this side. So let's have a look. So if carbon wants to share 4, I'm going to represent carbon by crosses, I think. So I'm going to put my 4 crosses in here, which means I need to do 4 dots like this. So then I'm going to check my carbon. I've got 1, 2, 3, 4. That's the 4. And then oxygen needs 6. So I've got 1, 2 here. So I need to make 6. 3, 4, 5, 6. And then the same on this side. I've got 1, 2, 3, 4, 5, 6. So let's check how many we've got in total. So 1, 2, 3, 4, 5, 6, 7, 8. Perfect. 1, 2, 3, 4, 5, 6, 7, 8. Perfect. Now I can draw the structural diagram. So remember we're writing out the letters again in the same order that they're there and drawing a line for each of the bonds. So here we go, like that. And in fact, actually, technically it should be just in a straight line like this. Okay, there we go.